morning. My name is Xavier Ducrohet.
I'm Tor Norbye.
Hi, and I'm Jamal. And welcome to What's New in Android Studio. So today we're going to talk about three distinct features: IDE enhancements, build system, and the Android emulator. So first topic, the Android Studio enhancements. So going back, at Google I/O, we launched Android Studio 1.3. And there we launched a whole host of features, including the C++ editor, data binding, and some new UI around SDK management. Over this past summer and fall, we worked on new vector assets, new HProc bug fixes, and a whole host of other features around Android Studio. And today, we're really excited to talk about Android Studio 2.0, today at the Android Dev Summit. So, features since Google I/O 2015. Before jumping into some of the 2.0 stuff, I want to recap some of the great stuff we worked on in the past few months. So for instance, we launched a GPU monitor. The GPU monitor allows you to look at your app as it's performing on your device and see the impact on the GPU calls for your device. We launched a network monitor. You look at the input and output calls of your device on the network while running your device on either an emulator or a real device. App templates. For the new app templates, we took a relook at those and added things like AppCompat, the design library, to help you get started on a new app or add new enhancement to a pre-existing application. Theme editor. Theme editor was a way for you to visualize your styles in colors.xml to get a recap of how your look and feel is going to look for your application and visualize those tweaks as you do your app development. And Vector Asset Studio. One pain point we talked about at Google I/O was about how to manage your rastery assets. Previously, you would have to manage 10 to 20 different assets per API level for your application. Today, you can import one of the vector drawable assets we provide for you from the material library, or you can import one of your own SVG files and place that in your application. And during build time, we will automatically generate all the raster images for you automatically, so you only have to manage one asset. And that's just an example of a few things. We had lint checks, better accessibility, bidirectional support, better test UI, logcats, and a whole host of things. And we're still investing. We're excited that we're still working on things that make your life more better as an app developer. And with that, we'll jump into the build system.
All right, thank you, Jay. All right, so let's talk about the build system. So, not working. Before we talk about InstantRun, we want to talk about just general build system improvement, right? InstantRun does not always activate, and so we still wanted to make sure that the build system would be faster than it used to be. So, we know of a few bottlenecks that are, I'm sure very obvious to you, whether it's DX or Progout or just the installation process. So let's go through a few of those. So the first fix that we did was we improved the DX merger. So when you build with Android, with a Gradle, and you have a lot of dependencies, we're going to predex all of those dependencies separately, running DX on each of them, and then at the end, we have a merge state. Now, the algorithm was pretty bad, unfortunately. It was a quadratic algorithm, and so more and more dependencies that you have in your project, the really slower it would get. The new one is linear. If you have a large number of dependencies, just the DX merger step could be at least an order of magnitude faster. It's available in 23.02, which we shipped a few weeks ago. So if your project is not yet using that build tools, you should definitely get it. The second thing that we did was we now run XInProcess. So I said we run a lot of predexing, a lot of different versions of DX in parallel. And for each of those, we would start a different VM. And that means you have the cost of starting the VM. That means that the JIT of the JVM does not have time to really optimize the code, and then it's really a lot slower. So we changed that in plugin 2.0. Also, it requires build tools 23.02, and it requires Gradle 2.4. The previous version would drop all the plugin code on every run, so that would not actually work. We recommend using 2.8 or 2.9 anyway, but you need at least 2.4. Simple setup, just do DX option, XInProcess equal true. For now, it's false by default. We want to get feedback, make sure that there's no issue. So let's look at some benchmark. This is I/O schedule 2014. There's about 15 or so dependencies, maybe a bit more than that. As you can see, both clean builds and incremental build are much, much faster. So that's pretty good. So on the left is the old plugin, the old DX, and on the right is the new plugin, the new DX, and XInProcess. Now, doing that has some trade-off that you have to think about. I'm sure some of you have done something like that, giving a few more memory to DX. Now, what happens here is that every calls to DX will actually get 2 gigs. So if you're predexing 4 different libraries in parallel, you have 4 DX running in parallel, and each of them gets 2 gigs. And now all of them will be in the same JVM, so you will need to get probably a little bit more memory. The other thing to think about is that this, when we pass that in your build Gradle, the Gradle JVM is already started, and you cannot change that after the fact, right? So it's only to control external process. So if you have that right now in your build Gradle, when you switch to the XInProcess, that won't do anything. You have instead to change Gradle.properties, give it more memory. You may already have done that because like Progout is already in memory, and Progout sometimes require a lot of memory. So you will have to play with that value. It may not be exactly like 4 times what you gave to DX before because there's different overhead, but you should play with the number. Do realize though that this is long lasting in the daemon. The daemon has a 3-hour timeout. So this memory will be used all the time, while before DX was really fire and then forget, and the JVM would disappear. Still, it's a very big speed gain, so you should definitely try it. Right now, we run up to 4 DX in parallels. You can control that through an environment variable, 100.dexter pool size. Give us feedback on the number that works for you, the memory, and things like that, and we may tweak the default values later. The second bottleneck I want to talk about is Progout. Now, Progout works great. There's no issue. If you're running it for your release process, not a problem. The problem starts happening when you have a really big application and you have more than 65K method, and you need to shrink it below the actual limit. So when you do that, then you need to run Progout on every debug build, and it's slow. The main problem, it's non-incremental. And the second problem is it disables predexing. And by that, I mean that when you run Progout, the output of Progout is a single jar, which means that you have to redex the whole application and its dependencies every time. And so we really wanted to fix that. So we've been working on a new shrinker. It's experimental right now. The big thing is that it has some incrementality, but the big thing really is that it enables predexing. So if you have, let's say, your main application plus 10 dependencies, the output of the shrinker will be 10 dependencies or 10 jars plus a jar for your code. And even if the shrinker has to do a full non-incremental run, it doesn't really matter. If it only touches one of those jar files, the other 9 jars will be the same, and Gradle allows us to just say, hey, those jars are the same. I don't need to redex them. I already have dexed them somewhere. And that's, again, a big speed gain. This is only a shrinker. Our goal is not to replace Progout. So the configuration is per variant. It doesn't do obfuscation. It doesn't do optimization. It's only a shrinker for debug mode only. And the other thing that it will allow us in the future is to do legacy multiText faster as well. Right now, if you first shrink with Progout to get below the C5K limit, but you're still above it, you have to enable legacy multiText if your min SDK is less than 21. So in that case, what happened is the process is, hey, we run Progout a second time because it was slow the first time, so let's running again. And so here, because we control the code of the shrinker, it's easier to keep the graph of dependencies and method calls and things like that, and actually run shrinker and multiText at the same time. So that will come later. Probably after 2.0, we want to stabilize first the shrinker for 2.0. It's not actually available right now in alpha 1 of the plugin. It will come in the next plugin in a few weeks. This is how you enable it. So you do have to enable minify still. But in debug, you would say use Progout false. And in release, you would say use Progout true. Actually, it's true by default, so you don't need to say it. But this is what would happen here. The result, so if we look at here, the first thing I want to mention, just to go back to the DX merger, if you compare the clean build on the first column and the clean build with shrinking on the first column, you'll notice that, hey, running Progout is faster. That's because, again, I said, Progout disabled merging of DX, and DX being so bad at merging, it's actually better not to do it. But anyway, we fixed that. So on the right column, you can see that, we're quite faster than before, almost 2.x, and that is running the shrinker in a non-incremental way. So as soon as there's a change, we rerun the full shrinking. If we run it actually in an incremental way, it's something that is not completely there, so I did not want to show the numbers. We get a little bit faster again. So it's not, like if you compare on the left side, basically doing a clean or an incremental build was just basically not different. And here we can get, hopefully, at least twice as faster than the clean build for incremental. So that's quite good. So that's the changes for actually building. Now we want to talk about deployment. Deployment is slow. We know ADB is slow. So we talked about it a little bit yesterday during the keynote. We'll have a new ADB push-pull protocol, much faster throughput. It's coming to the emulator soon, and with some system image, at least API 22 and 23, and we'll backport that later to more system images. So deploying faster is great. What we want to do also is maybe push less, right? So we have a new mechanism in Studio 1.5 that you may have noticed, where when you click the Run button, we first ask you, where you want to deploy it to, and then we build, and then we deploy. And before, we would do first build and then ask you. So this is something that is not related to what we wanted to do. But since we're doing that now, we figured, hey, maybe we can do something. So as a first proof of concept, we decided to do it to target specifically for your device in terms of density. So if you plug a device with MDPI, why package XHDPI, why package XXHDPI, and all of that. So APT does that for us in a very smart way. So if there's some assets that you do not have in MDPI, it will package another density, basically like the device would choose, right? If you have a device that has a density when you don't have those assets, it's fine some other assets to use. So here we don't gain a whole lot, only 10%, but this is still useful. But we do want to extend that to more things. So the things that you want to extend to, for example, are ABIs. Right? If you deploy to an x86 device, why build and package ARM code? Let's not do it. Right? So we'll do that next, and that would be for people who have native code a big gain. And then we want to do that for MultiText as well. It's not really packaging, it's more building this time. Right now, we tell you, hey, if you have to use legacy MultiText and you want it to be faster, create a variant for MinSDK 21 and above, so that when you deploy to, let's say, a Marshmallow device, it uses the native MultiText rather than the legacy. So here, we're basically going to be able to do that automatically. If you plug a 21, it will just build it with the native one. You unplug it, you plug a different one, and it will use the legacy one. That way, you don't have to think about changing the variants and deploying the wrong variant to the wrong device, and all of that will just take care of that for you. OK, so we saw building, we saw deploying. Now you have to install. So I took this small little app, right? IO schedule 5 meg, that's not really big. And I tried to install it on my Nexus 6, and the install was 12 seconds, which is just 12 seconds, right? It's awful. I mean, we have before and after, right? It's like, we made some really good progress on building, 2.4x, that's awesome. And then we add installation, and it's just bad. So, 18x is better than 28. 18 seconds is better than 28, but it's still just way too slow. So we wanted to fix that. And so that's why we did InstantRun, right? We really wanted to change the whole deployment cycle from end to end, not just focus on building, but look at everything. And we wanted to do that in a way that worked on older devices as well. So InstantRun. So what we want to do is we want to deploy as little as possible, so only what changed. We want to avoid installing, because as we just saw, it's 12 seconds. Or more if you have a much bigger application, right? It could be a lot more. And while we're at it, let's just not kill the app whatsoever, right?
So to avoid killing the app is not always possible if you made a completely structural change. But when we can leave it running, that's what we call hot swap. So the app is just running. If we have to mess with your app in more significant ways, but still leave it running, that's what we call warm swap. So a resource change will trigger a warm swap. Cold swap is not in the preview build, but that's where we restart your app in order to make bigger structural changes so that your objects have changed. And of course, the last one is full rebuild and restall. If you change something, for example, the app icon, we're going to have to do this because obviously your launcher wants to see the icon. We can't deal with that. But rebuild and reinstall is where you are today before InstantRun.
So let's see what happens actually when you do a full regular build with InstantRun, right? Because we have to prepare your application. If you take a regular application build with another version of Studio, we can't just go and replace stuff on the fly there. It's just not going to work. So the first thing that we have started doing is when you build with Gradle from Studio, we kind of do something a little bit different, right? So we kind of call Studio with, we call Gradle with an additional property saying, hey, you're in that special mode. And then Gradle, we create additional tasks in order to do more work than if you build from the command line. So we'll do bytecode instrumentation. We'll add a server to your app so that we can talk to it and things like that. So let's look at what it looks like. So this is a very simplified version of the build steps, right? We have the manifest merger that generates the final manifest that we package with APT, and then we have the Java C DX flow where we just compile and convert code. So the first thing that we do is we stop feeding DX with your regular classes, right? So we have a new API called Transform API, and I'll talk about that in my other talk on the Gradle plugin. And so we're going to do that by code instrumentation, and we're basically going to add a level of indirection to every method and constructor in your code so that we can go and replace stuff on the fly later. Then, I mentioned we need an app server because Studio will talk directly to the app, so we add that code to your app, and then, we just send that to DX. In order to actually start the server and add some custom class loader and things like that, we actually have to change your manifest. So we actually instrument, your manifest, we add stuff to it, and we add a new custom application class. And then we actually need to add that particular application class to your code. And that, if you have already your own custom application class, that the one that we use will proxy and delegate to yours so that it's transparent. You don't have anything to change, right? That was one thing that we really wanted to do is, as a developer, you shouldn't have to go and hack the code around to make the app work with InstantRun. It should just work. And then the final thing that we're doing is, in order to make sure that the connection between the app and Studio is valid, we generate a build ID on every build to make sure that we know what the current state is.
So when you're hitting the run button in the IDE, this is what happens. So we first make sure that you're actually using Gradle 2.0. And then we check the build ID, as I've just mentioned, to make sure that the device and Gradle are in sync. Because if they're not, if you've ran your device on a different development machine or whatever, it could be really, really bad if we put the wrong bytes on there that aren't incompatible. Then we make sure that we can actually talk to it. So we use the socket connection to the app. And then we check, is the activity in the foreground? And if all that's true, then we run Gradle. And Gradle is run with a different task, which basically would build up the DEX files. It then runs a verifier, which makes sure that everything that you've done in your code is compatible with the hot swap. And if it is, of course, we can do a hot swap. Otherwise, we'll do a cold swap. And the other thing we do for optimization is to monitor the files you're editing in the IDE. And the reason we're doing that is that allows the Gradle plugin to do certain optimizations. They're not technically necessary, but we're really looking for latency avoidance. And so if I've noticed that you've only touched Java files, we don't have to touch the resource task. Or similarly, if you've only touched the Java class, anything you want to add?
So right now, we only support hot swap in the main module. We'll add that to the sub-module. But one of the optimizations that we do is, if you change the code in the main module and you just ask Gradle to build, it doesn't know anything about the state. It doesn't monitor the file change at the moment. And so it's going to try to build all your sub-modules, which will be up to date. But because it doesn't know anything, it has to go and make sure that all the files haven't changed. And if you have dozens of modules, that can take a lot of time. Now, if you actually run it, you will see up to date, up to date, up to date, up to date, and nothing changed, and that's good. But it can still take some time. If you don't have an SSD, if you have slow I/O, whatever, that's going to take a lot of time. And so Studio knows. So Studio tells you, hey, only the main module changed, and then we just, same thing, add the Gradle plugin. We will just stop asking to build those, and then we won't even do the up-to-date check, and then it's much, much faster. So this is what happens once you get the actual file. So here you have Studio on the left, and then Gradle. And then on the right, you have your app. It's running, and it has a server, and it has that class that we just touched. So we call Gradle, and then here, that's it's a custom task. It's not a regular assemble debug that you would normally use. And we create a DEX file that contains only the classes that change. It could be 1, it could be 2, depending on how many you change. Then Studio grabs that, sends that to the app server, which gets ready to use a custom class loader to just load it. Now, the thing that's important is that when we load it, we don't actually load the same class that you actually wrote. The class is there. We can't replace it. So what we load instead is the special version. And that special version is created by Gradle itself during the bytecode transformation. And it's just an override of it. And then the app server will just basically call, modify the class here on the left to delegate every method call to the override. And that's because that version of the class is a special version, as I showed in the first graph, where we had that bytecode instrumentation. We go and we add that level of indirection. So here, the app server just makes the connection between the original class, saying, hey, now when we call that method, just go and call that version instead.
So for resource changes, we're currently relying on sending all the resources. So we have to run apt. So if you have an app that's really large with lots of resources, it's not going to be instant. So the InstantRun feature, I think, is really after the hot swap case. But there is an incremental apt underway that's going to really help with this a lot. And we have some short-term tricks we're going to do, too, to send a smaller portion of the resource file. And once we send it across the wire, we then use reflection hacks and I think there's no prettier way of referring to it, to actually make that running app restart the activity and apply the changes you made. There are some limitations to resource changes. If you change, for example, the app name or any resource that can be referenced from the manifest, we know we have to trigger a full rebuild. And the other thing is that until the preview build, we had some special optimizations where the R class was treated specially. So we would exclude field checks for them. But we saw some crashes, so to be on the safe side, if you have any ID changes as well, so if you drop in a new button in the layout editor, that's going to put an ID for you by default. Or even if you have plus IDs and you reorder them, that'll change the values in the R class. So those things right now will trigger a restart. And so for code swap, this is something that is not in the preview build. We'll demo it shortly. But that's when you have an incompatible change. So you've added a field, which currently is an incompatible change. And so we're working on basically making that be not a full rebuild, which it is right now.
OK, so there's a lot of things happening under the hood, bytecode instrumentation, replacing class on the fly, but we wanted it to be as easy for you as possible, right? The user interface for InstantRun is just like the run button that you've used before, right? So the goal is that Studio knows whether we can do InstantRun, whether we can do cold swap, warm swap, hot swap, anything. You don't have to think about it. If there's a little lightning bolt right next to the run button, then you know that you'll have InstantRun. But just keep pressing that button or using the shortcut, and it will just happen. And hopefully, the best scenario will happen, without you having to do anything. Now, because we talk directly to the app, and we send stuff, on the fly, something you could be in a weird situation where we replace some code, but because the state can be weird, there is a stop button. So if you do that, it will kill the app, and then on the next run, it will do a regular, hopefully cold swap at some point. But for now, a full rebuild. And then you have a shortcut also to restart the activity, right? There's some case where we replace stuff, but we can't actually apply it. So we have a shortcut for that.
All right, demo. Can we get stage 2? All right, so here is an old project. You can see it's using the ancient Gradle plugin 1.5. And if you bring up the preference panel and you go to the InstantRun settings, you can say it's telling me right now that I don't have InstantRun because I need to update my project. What that will do is it'll update to Gradle 2.0, but it'll also give you build tools 2302, which isn't necessary, but really it's going to be much faster.
You should use them anyway. So.
Yeah, and Gradle plugin 2.8. All right, so here I'm going to switch to a different project, the Topeka sample app, which I've already run on the device. So let me show you some of the InstantRun stuff. The first thing we can do here is we can change some resources. So CSS sign in at the top. Let me open up the translations editor and find the sign in string. And we'll just change it to welcome, sign in. And if I hit the InstantRun button, it now performs a incremental build. It grabs the whole resource file, and it sends it over. And it restarts activity. You can see it says, welcome, sign in over here. If I switch to the theme editor, I can make non-string changes too. So let's, for example, go and change the primary color to material red, material pink. Yeah, we'll do red. And we can also change the status color for the device, which I thought was, now I can't see it. There it is. So we'll switch that to, let's say, this one. And again, if I press InstantRun, it packages the resources, the app is still running, and it applies those changes. So let's make some code changes. So if you look at this grid of icons over here, the number of icons is dynamic. It is based on the size of the avatar icons and the size of the screen. And it's done by this method right here, calculate span count. I can just go and change this code. Let's say this is hard-coded to 3 for now. And if I press InstantRun, you can see that nothing happens. And you can see that it was saying in the toast, we've made this change for you, but you may want to restart activity. And that's because this code is only run on create. Right? So just because I've hot swapped, it doesn't really make the change visually appear. But there's also a bubble we're showing in the bottom left corner here saying, hey, you haven't restarted activity. Would you like to do that? It's telling you what the shortcut is for doing it. Or you can also configure it by options. So if I, first of all, I'll turn the option on. But I'll also just apply it manually right now, Control-Shift-R. You can see we've got our 3 columns. And now if I switch it to 4, for example, and press Control-Run, you can see it's nearly instant, right? 4 columns. So that's basically the hot swap case and the warm swap case with the resources. Now I'm going to show you cold swap. So cold swap is not actually enabled. And the reason for that is primarily that it's really, really buggy. So you can see I have an option here called demo only, and that's because this is not available in your build. But I'm going to show you what it does when we hopefully get it working. So let's put the real code back in, and let me do some method extraction here. So I'm going to actually extract this whole line. We'll call it getAvatarSize. Oh, and the IDE noticed, hey, this is a pretty generic method. Let me try to generalize that for you. So now it's basically turned it into something different, which I'll call getDimension. And then we'll extract this expression over here to calculate columns. Right, so now we have some structural changes. And because I did a turned on code swap, if I hit run now, it's going to kill the app and restart it. But it's not doing a full build. You can see it's the little bubble saying, hey, method added. We couldn't really restart it. But now the app is back and running, and it's running the new code, although it's the correct code. So let me change it to prove that this new method can do the right thing. So InstantRun, 2 columns from the new method. So that's code swap, which hopefully we'll get working soon. The last thing I want to show you is data binding. So data binding also broke for the preview build. We have it working in the night lease again. Actually, let me just run it first of all. So this is a sample app I found in the data binding code repository. I don't know what the app means, but it has some binding expressions I can show you. So while that's starting, let me show you the stuff we have for data binding now. This is not integrated in the preview build, but we've finally, you could say, added code completion for expression language stuff. So here, not only can I navigate between symbols and into methods and data objects, we also have full code completion here on all the attributes and all that stuff. So that's nice. So let me just, as you can see in this app here, we have uppercase characters in some of these name cards. If I were to change this to lowercase and do instant run, you can see that, hopefully, soon. Yeah, it applied the change, and you can see it's now lowercase. So data binding is working too, and that'll hopefully make data binding and instant run work really well together. I think that's it for the demo.
Right.
All right, so Android emulator. So we talked about the Android emulator at the keynote yesterday, and we really wanted to invest time and effort into the product because we knew we use it all the time as a developer, but it hasn't been as great as we wanted it to be as a team. So the 2 things we worked on. First is performance, and the second thing is usability. And we think of performance in 3 different ways for the emulator. It's around CPU, GPU, and I/O. So for CPU, what we added to the emulator is multi-core support. What it allows you to do is that you can actually process your apps faster, install them faster, and get a more performant experience in the emulator. For GPU, we've had a kind of strong offering so far. We've added additional GL calls, so you actually can support more GL applications and get a more performant experience while using OpenGL ES. And the third column we added is I/O. So Zav touched on about ADB push speeds. We also looked at the I/O speed on the actual virtual device. In itself, it's like a little mini hard drive. We actually improved that very dramatically in order to improve things like install time and processing time. So let's look at some data to sort of highlight that particular data point. And so we looked at the Google Play Store and tried to find the biggest app possible to kind of highlight this particular scenario. And we found one. It's about 45 megabytes. It's quite extreme. Most developers don't have apps this big, but let's just use this as an example. So in the past, the Emulator 1.0, it would take just under 300 seconds to install and push that application. Most of the time, as indicated by Zav, is that it's actually on the install part. In a few seconds, you can push it across the wire, but it takes a long time to process. That same application on the Nexus 6 was just under 150 seconds. That's OK. We thought we could do better. So with the Android Studio Emulator 2.0, we're now just under 45 seconds for that same push. So usability. So again, the emulator has been around for some time. We've had a lot of great features, but most of them have been under command line. Not very easy to use, not very intuitive. Again, if you're trying to develop your application and try out different scenarios, it's very difficult to remember some keyboard shortcut. We have shortcuts now, but remember some archaic ADB push command or some command just to get your app running or to try out some scenario. So we decided to invest on a new UI to address this. So let's jump to stage 1 demo, please. OK, perfect. So this is the new UI for the Android emulator. We showed a little bit of this at the keynote yesterday. So of course here, let me just open up Google Maps here, my recents. All right, so as before, you can use the emulator to type in directly into the UIs for quickly typing. So let's go to New York. And again, with OpenGL, we can quickly render this really quickly with the UI to render all the maps. But in addition to just allowing you to enter in GPS points, we've also allowed you to input KML files. So here on the right-hand side, I have a table of GPS points. And this right now is a path I want to test out for my application. So let me turn on the GPS location here on the emulator. That's pressing that blue button here. Let me speed this up to 2x for the demo here and press play. And what's happening now is that I'm now pumping in points to my emulator. This is actually the Googleplex. And you can kind of move through the emulator experience and kind of repeat that process for your applications if you use location in your emulation. Cool. All right. All right. So moving on to the next tab is around cellular. Now, some developers had asked about, hey, how do I have some way to control the speed of my network? So let me just kind of zoom into this the tab here. OK. So you can control here on the network type. If I want to change it to 2G, if you notice here on the notifications, it's currently saying 3G Android. Changing this to Edge will change this to 2G. You can change that to E for Edge. Let me pull that back to full for this demonstration. Or if I want to change things like, hey, what happens if I'm roaming? I can quickly change that on my data connection. That changes from an E to an R for that icon. Or if you want to see what happens if an application has no service or the SIM card's out, how do I sort of simulate that situation? And here I can simulate that on the cellular tab as well. Again, this is just to help you out to figure out your different data connections as you're testing out your application. OK, so moving on to battery. So battery here, let me just open the battery here on this UI. Great. So as you can see here, I can move the charge level here with the UI. That's straightforward. I can say, hey, I want it to be charging. It can be an AC or not charging, so I can change the state. That moves it to not charging. So straightforward there, just a way for you to toggle that if your app uses any battery kind of configurations. We now have a UI for you to manage that as well. Great. All right, so now moving on to phone. So at the keynote we talked about, you can actually receive phone calls from the emulator. That's what your app does. But we also can send SMS messages if that's what you need to test as well. So in this case, I sent myself a text saying, hey, don't forget the marshmallows. That's great. We'll come back to that. So let me go back to sensors. So at Google I/O past year, we talked about fingerprint. And fingerprint is a way for you to authenticate your application, either for payments or for security for your device. And we've added that feature into the emulator itself. So if you go under settings, we have fingerprint here under security. Great. Fingerprint. And here we can ask you to add a fingerprint to unlock your device. You click continue here. And this is from a pin. It says super secure for ones. Great. All right. And then we have this fingerprint tab here. And what this allows you to do, it has 10 input points for 10 fingers on your hands. And let's say I wanted to use my finger 1, touch the sensor. Boom, it's authenticated. Now you've added fingerprints into your device, and now you can use this for your testing for fingerprint for your applications. OK, great. So last few things here. So in settings, if you don't like dark, we have the ability for you to switch to like light theme if that's your option here. So you go to light. That's the light theme of your emulator, so you can see how that works. My personal favorite is dark, so I'll put it back to dark here. All right, and then we're just going to close this extended controls here. So we talked about the drag and drop capability. So in addition to being able to install APKs, drag and drop, we also allowed you to install media files. So let me go to my SD card, and let's go to download here. Let me rotate, because rotate's also available here, which is great. So I can rotate that very easily. Let me resize this so we can kind of see this together on one screen. Okay. So I have a picture here I wanted to get on this device. So I can simply drag this onto my emulator window. And there you go. So this is my picture. So, picture there. Great. Okay, cool. All right. That's okay. So then let's go back to that SMS here. So I sent myself that text message. So let me just rotate this back again. So let's go back to this. All right. And let's go to that message. Here we go. All right, so there's that text I sent to myself. All right, let's make this a little bigger here so we can see this. Right, I can resize that with a corner. And again, with the keyboard, I can just type messages here on the keyboard. And so then lastly, I'll say, thanks for coming to Android Dev Conference. Cool, spell check's also included here. Great, conference, and send. That's it. Great. Can you switch back to slides, please? So we talked about a lot of different features here at this session. And so a few things are going to be available now. So things like DX merger, InstantRun is available today on the Canary channel. And coming soon, we're adding the shrinker, the emulator, and APT. Or actually, the APT is coming later on this in a few weeks. And so with that, I think that's...
Yeah, we have time for questions.
A little time for questions. Cool. So questions.
We were supposed to tell people to line up.
Oh, yeah, there's some mics over there, so you need to go to the mics so that everyone can hear.
Hi, my question is, can Android emulate the Android Wear connectivity to the Android phone emulator?
Yes. So if you load up an Android Wear AVD with a device, we automatically simulate that Bluetooth connection, so you can send messages between your Android Wear and the device.
Thank you.
Hi. Do you know if you can modify the network settings in the emulator so you can point it to a proxy, a local proxy, if you want to use like Charles or something like that to sniff network traffic?
You want to say that one more time?
Point the Wi-Fi connection on the emulator to a local proxy so you could sniff network traffic, like using Charles proxy or something like that.
I don't think so. Let's talk afterwards.
I think we don't have Wi-Fi emulation because there's only one network connection on the emulator right now. It's something we're working on. So right now you only have basically the network connection. Okay. But it's something we want to fix.
Cool, thanks.
Okay. Let's go to this side.
Hi. You mentioned better GPU support in the emulator. Which versions of ES can we play with now?
So we're shipping with Android, OpenGL 2.0, and we're working on 3.3.0. Yeah.
Thank you.
Is that possible to run the InstantRun from the command line?
No. The reason for that is that a lot of stuff we're doing is, in particular, the socket connection is from the IDE, not from Gradle. So the IDE is really central to InstantRun. A lot of the tasks you see, like actually preparing, performing the incremental DEX file creation, is done. You can just look in the Gradle console to see which tasks are running, plus that command line flag that was in Xavier's slide. But no, you need the IDE.
So one more question is about the emulation. Is that possible to simulate the SIM card?
We are going to add the SIM card soon. Yeah.
Thank you.
Okay.
Hi. On the NDK side, when will you be adding support for building static libraries and native-only libraries from Android Studio?
So it's actually it's a good question. So we just added, I'll talk about it a little bit in the next talk about Gradle, but we just added, we did support for modules that only build native code.
Okay.
And we also just added inter-module dependencies because the NDK is built on the new version, new APIs on the Gradle side to do plugins. And in the previous version, we didn't have inter-module dependencies because they handle that differently. So we have inter-module dependencies, and there's an option to do like a static linkage between different modules. So you should be able to do that now.
Okay. Thank you.
So the Android emulator currently supports doing fingerprint by by touching, but it really only supports happy path, i.e. you either touch finger 1 or 2, and not any of the like finger move too fast or some of the error scenarios. Is there any plans to add that in?
Yeah, so it's not going to be the initial release for that, but we are planning to add more fingerprint test conditions.
Thank you.
Yeah.
Also on the emulator, excuse me, is there any support for other device sensors, accelerometer, gyroscope, ambient light, any of that kind of stuff?
Yeah, so that's in a future release. We didn't show that today, but definitely that's on our roadmap to get that out. Yep.
I was wondering for the connectivity settings on the new emulator, is it possible to simulate partial or total packet loss?
So there is a data drop connection that's on the emulator. It's okay. We're working on creating a more enhanced version of that, but today you can say I want to like degrade to 2G network, and you can simulate that situation today.
So you showed a demo that simulated the location changes. I'm assuming that's intended for the geofencing API, testing that out. And you also mentioned the support for KML files. What about GPX files?
Yeah, so we parse GPX and KML.
Okay.
Yeah.
So when you install with InstantRun, is that a normal standalone APK? So if I then disconnect the device, take it away, is that still going to work in the same way, or does it rely somehow on being connected to Android Studio still?
No, it runs just fine. Yeah, the only thing is that it does some extra stuff, like listen on a certain socket, but the app is a self-contained APK that has everything and it can run anywhere.
Great, thanks.
Is there any sort of SDK so that for some of these emulator features, so if we're running integration tests on emulators and that kind of stuff, we can control some of the settings?
Yeah, that's not in the first release, something we've been thinking about, but we're definitely planning on working on that, yeah.
Will the new emulators support headless mode for continuous integration servers?
So that same point, so we are looking at the remote testing application for that. So we're definitely planning to do that.
So the Logcat view in Android Studio kind of is not great. Like it still doesn't have the column view that Eclipse had, kind of sorting your tags and your timestamps, and the filtering doesn't seem to be as robust, and half the time it seems like it loses the connection to the device.
Well, the connection wouldn't be Logcat. We know that ADB has been pretty flaky, particularly on some platforms, and I think the newer version of ADB is actually better, so you should definitely install the preview version. That's what we use for the demo because InstantRun really wants an ADB connection to be reliable. On the, what was the other point?
There's also, so we also replaced Logcat.
What we've done is in 1.4, we made Logcat quite a bit better. So before that it was terrible, now it's better, although it still doesn't have the table sorting. Part of the reason for that is that we're actually using a console widget, which gives us some other stuff. For example, we can collapse stack traces and things like that in a much smarter way with the auto expand. In the 2.0 preview, we've done some more work. So actually, it might have been in 1.5. We show dead processes, for example, right? So once your process dies, you can still find it in the process list. And for 10x, where we do code swap, the process changes. It was very important for us to actually associate the two together. So we've done that as well.
But we know that we need to improve it. We have some work planned for it to rewrite the UI.
I usually use it from the terminal, just so you can have multiple tabs, or you can have different sortings, where Android Studio is kind of pretty inflexible about that.
Yeah, we want to fix that. That's
I was wondering if you considered any impact of the bytecode for InstantRun for developers who might be using MAT and trying to profile their apps, considering, looking at performance tools and such.
Right. Are you asking about the overhead of the indirection?
More or less, yeah. Instrumenting the bytecode has to have some impact, and
yeah, I definitely wouldn't do profiling in the InstantRun mode. I'd probably turn off InstantRun when I'm going to measure. In our experience, it hasn't been a noticeable lag, I would say, but results may vary, I guess.
Yeah. I mean, for memory, it shouldn't impact it too much anyway. There is an instance of each override class, only for the classes that you replace, of course. But because you mentioned Matt, right? And so there won't be any, there should be no memory changes, right? We're not allocating a lot more objects. We're not doing any of that. So for memory, there shouldn't be any issue. For performance, yes, there's definitely something. If you do actual method tracing, you're going to see all those overrides, delegation, and all of that.
I guess the main cost is the stuff we add that counts towards the 65K method limit.
Right.
Right. That's another problem. I guess I was wondering if the bytecode had been measured, like you're testing with a 5 meg app, the I/O app.
Measured in terms of performance?
No, just the difference in size, for example, when you install using InstantRun.
It's very tiny. It's basically the same
app. It might be nice to see
just
those numbers was all, because for 5 megabytes, maybe it's really tiny, but if you're doing
it shouldn't be proportional. It should. It's basically, and in fact, we only touch your code, not the library code, which makes a big difference. So when you're using large libraries like Play Services and Design Library and AppCompat, we're not going and instrumenting those. We only instrument your actual app code that we think you will change. And so that's a pretty small amount of code, actually.
Usually.
Yeah.
Not necessarily.
Yeah. No, we are aware of some code bases that are pretty large.
Yeah, so did you want to talk about MultiText at all?
Well, one of the nice things that Zav mentioned is that we now target it to the device you picked. And a lot of developers target newer devices. So if you're 21 and up, we can use the, what is it called, non-legacy multidex? What is it called? Native multidex.
So we don't do that yet, but we'll do that soon. The one issue to think about for multidex is if you're in legacy multidex and your app is very close to the 65K limit, and adding that extra app server and stuff like that may bring you over the limit. And in that case, you would have to figure out what to do in your app to reduce the amount of classes that you need upstart.
So we're out of time. You're out of time. So if you have more questions, please see us in the sandbox over there. And thanks for coming today.
Yeah, thank you.